Right now, in the time it takes you to blink, over 5 million emails are sent, 100,000 YouTube videos are watched, and 1 billion cat pictures travel across the entire globe. But here's the wild part. None of that happens through magic or thin air. It all shoots through giant spaghetti-like cables buried deep under the ocean. Mind-blowing, right? So here's the question that should keep you up at night. How does a photo you snap in New York end up on your grandma's phone in Tokyo in less than 1 second? That's faster than you can say grandma. The answer involves cables, light beams, and a surprisingly clever system built to survive nuclear war. Seriously. Let's start with the basics. The internet is simply a massive network of computers all talking to each other. Think of it like a giant Lego city where every house is a computer, and every road connecting those houses is a cable or wireless signal. That's it. No magic, just a really, really big neighborhood. There are 3 key players you need to know. First, the network. A network is just a group of computers connected so they can share information, like friends passing notes in class. Second, the server. That's a super powerful computer that stores websites and sends them to you when you ask, like a librarian fetching your book. Third player, the client. That's you, your phone, tablet, or laptop, the device doing the asking. So every time you open a website, your device is the client asking the server, hey, can I see that page? And the server says, sure, here you go. This conversation happens in milliseconds, thousands of times a day. Now here's where it gets really cool. When you send a message or load a website, your information doesn't travel in one big chunk. It gets broken into tiny pieces called packets. Imagine splitting a pizza into slices and sending each slice on a different delivery bike. All the slices eventually arrive and get put back together into one delicious pizza. Here's how packets work step by step. Step 1, your message gets chopped into small packets. Step 2, each packet gets a label showing your address and the destination address. Step 3, packets travel through devices called routers. Think of them as Lego traffic cops, pointing each packet in the right direction. Every packet finds its own path. Step 4, the packets may take completely different routes to get there. One might go through Paris, another through Singapore. Step 5, the destination computer collects all the packets and reassembles them back into your original message. Like snapping a Lego set together after all the pieces arrive in separate boxes. The final result looks perfect. The little label on each packet is called an IP address. Every device on the internet has one. It's like your computer's home address, a unique string of numbers that tells the internet exactly where to deliver your data. Without IP addresses, packets would just wander around lost forever, like a pizza delivery driver with no GPS and no address. Chaos. Now let's talk about the physical internet, the part most people never think about. The internet is not floating in the sky. It's not stored in clouds. About 95% of all international internet traffic travels through submarine fiber optic cables laid across the ocean floor. Real cables, real ocean, real floor, right now under the water. These cables are only about as thick as a garden hose. But there are over 400 submarine cables stretching more than 1.2 million kilometers under the ocean. That's enough cable to wrap around the Earth over 30 times. And light pulses travel through these cables at nearly the speed of light itself. That's how your video loads so fast. Here's the weirdest fact about submarine cables. Sharks have actually bitten them. Real sharks attacking real internet cables, causing real internet outages. Nobody knows exactly why sharks do this. Possibly they're attracted to the electromagnetic fields. So yes, technically, a shark can ruin your Netflix night. The ocean is wild. Now here's the most mind-bending fact about the entire internet. You might think it's perfectly organized, like a tidy instruction booklet, but it's actually chaos by design. The internet was built to be unpredictable and messy on purpose. And that messiness is exactly what makes it so incredibly powerful and nearly impossible to destroy. Back in the 1960s, the US military built a network called ARPANET. The genius idea was simple. If one city gets destroyed in a war, the network automatically reroutes data around the damage. There's no single master computer running everything. No headquarters, no off switch. It was literally engineered to survive a nuclear attack by working even with huge chunks missing. This means the internet is decentralized. No one owns it. No one controls it from one single place. It's more like a living organism than a machine. Even if massive parts of it disappeared overnight, the rest would keep working, automatically finding new paths around the damage. The internet was built for the apocalypse, and it's still running just fine. Okay, but how does your computer know where to find Google when you type google.com? Your computer doesn't actually understand words like google.com. It only speaks numbers, IP addresses. So there has to be a translator, something that converts the human-friendly name into a computer-friendly number. That's where DNS comes in. DNS stands for Domain Name System. It's basically the internet's giant phone book. When you type google.com, your computer instantly asks a DNS server, "Hey, where does Google live?" The DNS server checks its enormous database and replies, "That's at IP address 142.25.80.46, and off your request goes, all in milliseconds. Without DNS, you'd have to memorize a string of numbers for every website you want to visit. Imagine telling your friend, "Check out 172.217.40.238. It's hilarious," instead of "Check out YouTube." DNS makes the internet human-friendly. It's one of those invisible systems that quietly makes your life way easier every single day without you ever noticing it. Let's put it all together with a real example. Say you want to send a meme to your best friend Jake. It's a picture of a dog wearing sunglasses, obviously very important. You hit send. At that exact moment, your phone springs into action and begins one of the most impressive chain reactions in modern technology, all to deliver a dog photo. First, your phone immediately chops that meme into hundreds of tiny packets. Imagine cutting the dog photo into 200 tiny Lego pieces, each one numbered. Then each piece gets a little label, from your phone in London to Jake's phone in Sydney. This is piece number 47 of 200. Every piece knows exactly where it came from and where it needs to go. Then the packets zoom off in all different directions. Some travel through fiber optic cables under the Atlantic Ocean. Some bounce off satellites in space. Some pass through 12 different routers in 6 different countries. Each router reads the label and passes the packet towards Sydney. It's like a giant global relay race with 200 runners going different routes. Jake's phone starts collecting the packets as they arrive, not necessarily in order. Packet 150 might arrive before packet 3. That's completely normal. Jake's phone keeps a checklist and waits patiently. Once all 200 pieces arrive, it snaps them back together like a Lego set. And suddenly, there's the dog in sunglasses, perfect and complete. Total travel time for the entire meme, less than half a second. Jake's reaction time to actually laugh, 3 full seconds. So the most advanced communication technology in human history successfully delivered a dog photo and then waited patiently while a human processed it. The internet is working exactly as intended. Jake is the bottleneck. So let's quickly recap everything we've covered. The internet is a global network of computers connected by cables and wireless signals. Data travels as tiny packets, each labeled with addresses. These packets take different routes and get reassembled at the destination. It all happens so fast you never notice the incredible complexity happening under the hood. Most of the internet runs through underwater cables, no thicker than a garden hose. The whole system was designed with zero central control, intentionally resilient and nearly impossible to shut down. DNS translates human-friendly website names into the number-based addresses computers actually understand. These three systems work together every millisecond of every day. Here's what really gets me. The internet isn't magic, but once you actually understand how it works, it becomes something way more impressive than magic. Every time you load a video, send a text, or search why cats hate cucumbers, you're using one of the most complex and clever systems humans have ever built. And it mostly just works, quietly, invisibly, every single day. Think about the scale for just 1 second. Every minute, 500 hours of video are uploaded to YouTube. Over 300 billion emails are sent every single day worldwide. All of that moving through cables thinner than a garden hose, guided by routers labeled with addresses, broken into packets, and reassembled perfectly at the other end. Every time. Without you doing a single thing. The next time your Wi-Fi is slow, just remember, your complaint is traveling through underwater cables, bouncing between satellites, passing through a dozen countries, getting translated by DNS servers, and then coming back to you. All in milliseconds. Maybe cut the internet a tiny bit of slack. It's doing a lot more work than you think behind that little loading circle. The internet was invented by humans trying to solve a problem. How do we share information even if part of the system breaks? That one question led to a network that now connects over 5 billion people. And it all started with a bunch of scientists sending text messages between a handful of computers in the 1960s. One small step for a computer, one giant leap for cat videos. And now you know how the internet actually works. Go tell someone at dinner tonight, watch their face. You just went from casually using the internet to understanding the global infrastructure of cables, packets, routers, DNS, and decentralized chaos that makes the modern world run. That's not a small thing. That's genuinely impressive. Nice work.